Welcome back to Korea Market Explained. Last episode we covered why KOSPI woke up after a decade. Today we go deep on the single biggest driver behind that move: memory chips. Here's a question worth sitting with. Everyone knows NVIDIA is the defining company of the AI era. H100, Blackwell, Rubin, the chips that train the models that are changing everything. But there's a bottleneck that NVIDIA can't solve on its own. It's not compute, it's memory. Every single NVIDIA AI chip, every H100, every GB200 is stacked on top of Korean memory. Without it, the GPU doesn't ship. The memory market is roughly a three-player oligopoly. Samsung, SK Hynix, and Micron control over 95% of global DRAM supply. Two of those three are Korean. The HBM market, the premium memory that AI chips specifically need, is projected to grow from $38 billion in 2025 to $58 billion in 2026. And some forecasts have it crossing $100 billion by 2028. To understand why this matters for Korea, you need to understand two things. First, what DRAM actually is and why it's so cyclical. And second, what HBM is and why it's different. Let's start from the beginning. DRAM, Dynamic Random Access Memory, is the short-term memory of every electronic device. Your phone, your laptop, your server, your GPU. Every time you open an app, stream a video, or run an AI model, DRAM is doing the work. It's been around for decades, and for decades, it's been one of the most brutally cyclical industries in tech. Here's how the cycle works. When demand is high, prices spike. Manufacturers make huge profits. They reinvest, building new fabs, expanding capacity, but fabs take 3 to 5 years to build. By the time that new supply comes online, the demand cycle has often already peaked. Oversupply hits, prices collapse, manufacturers cut investment, capacity tightens, and the cycle repeats. This chart shows DRAM revenue going back to 2018. You can see the pattern clearly. 2018, a boom. 2019, collapse. 2021, recovery. 2023, the worst crash in 14 years. But here's what makes DRAM different from most cyclical businesses. The number of players has shrunk to almost nothing. Decades of brutal cycles wiped out most competitors. What's left is Samsung, SK Hynix, and Micron, three companies controlling the memory of the entire world. The 2022 to 2023 down cycle was one of the worst in memory industry history. After a pandemic-driven boom, where everyone bought laptops, monitors, servers, anything with a chip, demand fell off a cliff. Consumers stopped buying. Enterprise spending froze. Inventory piled up across the supply chain. DRAM prices fell by more than 50% from peak to trough. Samsung's semiconductor division went from earning 23.8 trillion won in 2022 to losing 14.9 trillion won in 2023. That's a swing of nearly 40 trillion won, about 30 billion US dollars, in a single year. SK Hynix posted its worst loss on record. Micron laid off 10% of its workforce. The entire memory industry bled, and yet, this is the thing about cyclical businesses, the worse the bust, the bigger the seeds of the next boom. Because when prices are this low for this long, manufacturers stop investing, supply growth slows, and when demand eventually returns, there's nowhere near enough supply. That's exactly what happened next. The cycle turned in late 2023, inventory that had been clogging the supply chain finally cleared. Samsung started cutting DRAM production, unusual for a company that had historically favoured volume over price discipline. SK Hynix redirected capacity toward HBM, and then AI lit the fuse. Contract DRAM prices started climbing in Q1 2024, slowly at first, 15 to 25% per quarter, then faster as AI data center build-outs accelerated. By November 2025, contract DRAM prices had surged over 420% from the trough, from around $1.50 per gigabyte to nearly $19.50. DRAM inventory at customer sites dropped from 12 weeks of supply in late 2024 to just 2 to 4 weeks by late 2025. The market had gone from drowning in chips to not being able to get enough of them. By Q1 2025, SK Hynix had overtaken Samsung as the world's largest DRAM maker by revenue, for the first time in history, a title Samsung had held for decades. Something structural had shifted, and that something was HBM. So what is HBM, high bandwidth memory, and why does it matter so much? To understand it, you need to understand the problem it solves. Standard DRAM sits on a separate chip connected to the processor via a bus. That connection is a bottleneck. The processor can compute far faster than it can fetch data from memory. In the AI world, this is called the memory wall. When you're training a large language model, something like GPT or Gemini, You're moving enormous amounts of data back and forth between the compute cores and memory, millions of times per second. With standard DRAM, the memory bus becomes the limiting factor. Your $30,000 GPU sits idle waiting for data. HBM solves this with a different physical architecture. Instead of a chip sitting beside the processor on a flat board, HBM is a 3D stack of memory chips, 8, ARB12, 16 layers, connected directly through tiny vertical channels called through silicon vias, or TSVs. This stack is then placed right next to the GPU on the same package, separated by just microns. The result is a memory interface that is roughly 10 times wider than standard DRAM, 1024 bits versus 64 bits, which means data can flow much faster. HBM3E, the current generation, delivers around 1.2 terabytes per second of bandwidth. The upcoming HBM4 doubles that to over 2 terabytes per second. For comparison, a standard DDR5 memory module does about 50 gigabytes per second. That's a 40 times difference. This is why NVIDIA doesn't use standard DRAM in its AI chips, and it's why every H100, every GB200, every future Rubin GPU is physically stacked on top of Korean memory. But here's what most people miss when they talk about Korean chips. It's not just Korea. Building one AI chip requires a handshake between two countries that can't easily be replaced. It starts in the United States. NVIDIA, or AMD, designs the chip. That design goes to Taiwan, where TSMC fabricates the GPU logic die on its most advanced process nodes. Then Korean memory, SK Hynix or Samsung HBM stacks, gets assembled alongside that GPU. But those two pieces don't just snap together. They require a highly specialized packaging process called CoWoS, chip on wafer on substrate. And right now, only TSMC can do that at the scale AI customers need. So TSMC appears twice in this supply chain, once as a chip maker, once as a packager. The result, Korea controls roughly 88% of global HBM production. Taiwan is the only country capable of turning that memory into a working AI chip. One AI chip, two countries, no substitutes. That concentration is either a massive competitive moat or a geopolitical risk, depending on where you sit. HBM isn't a single product, it's a fast-moving generational race. HBM2E powered the first wave of AI chips, NVIDIA's A100. HBM3 and HBM3E are in today's H100, H200, and Blackwell GPUs. SK Hynix and Samsung have both been delivering HBM3E in high volumes through 2025. HBM4 is the next battleground. The JCE DEC standard was finalized in April 2025. It doubles the interface width to 2048 bits, enabling over 2 terabytes per second per stack. SK Hynix completed development and started mass production in late 2025. Samsung has been delivering final qualification samples to NVIDIA. Micron began shipping HBM4 samples in June 2025. Beyond that, HBM4E is already being developed for 2027. TrendForce estimates HBM4E will account for 40% of total HBM demand in 2027. NVIDIA's Rubin Ultra platform, targeting 2027, is expected to carry HBM4E. The pace of development here is relentless. Each generation requires more complex stacking, more precise manufacturing, and tighter partnerships between memory makers and GPU designers. This is not a commodity business anymore. This is co-engineering at the frontier of physics. Now let's talk about the race itself, because the HBM story is really a story about two Korean companies going in opposite directions, and then one trying to claw back. By Q3 2025, the most recent full data we have, SK Hynix held 57% of the HBM market by revenue. Samsung had recovered to 22%, Micron sat at 21%, but the headline number that tells the real story, SK Hynix beat Samsung in operating profit for the first time ever in 2025, 47.2 trillion won versus 43.6 trillion won, a company less than half Samsung's size in total revenue, out-earning it for an entire year. For context, Samsung is the largest memory company in the world by capacity. To be sitting at 22% in the most valuable part of the market, having slipped as low as 17% in Q2, is not where they expected to be. How did SK Hynix get so far ahead? They made a bet early. While Samsung was optimizing for volume and yield across all DRAM products, SK Hynix focused on HBM as a strategic priority from around 2018. They built the engineering depth. They developed the packaging expertise. They became NVIDIA's primary supplier. NVIDIA accounts for roughly 90% of SK Hynix's HBM shipments. That relationship is now deeply embedded. co-engineered at the chip level. SK Hynix's HBM4 is already confirmed for NVIDIA's Rubin platform in 2026. Samsung, meanwhile, struggled with yield issues on HBM3E. Their chips failed NVIDIA's qualification tests in 2024. While SK Hynix was shipping, Samsung was reworking, but Samsung is not standing still. By Q3 2025, they had recovered to 22% HBM revenue share, up from 17% in Q2. Q4 2025 was their best quarter ever. 20 trillion won in semiconductor operating profit. They've announced plans to boost HBM capacity by 50% in 2026, and Samsung's HBM4 hit an industry-leading 11.7 gigabits per second, with full-scale shipments to NVIDIA starting February 2026. The gap is narrowing, but SK Hynix has already locked in over two-thirds of NVIDIA's Vera Rubin HBM4 orders. The race is real, and it's only getting more intense. Now, the risks, and there are real ones. The first is the one you'd expect from any cyclical business. The next, down cycle. The current shortage is extreme. DRAM inventory is at multi-year lows. Prices are at multi-year highs. But history is unambiguous. Every DRAM supercycle ends. New fabs are being built. Supply will eventually catch up. Tech Insights forecasts an industry downturn beginning around 2027. The typical cycle from trough to peak to mean reversion is 2 to 3 years. We're now well into the upswing. The second risk is China. CXMT, Changshin Memory Technologies, is China's leading DRAM maker. Today, they're years behind on standard DRAM and nowhere close on HBM. But China is pouring enormous resources into memory self-sufficiency. Initial HBM class products from Chinese makers are expected around KOSPI 2026. Whether they can hit the yields and performance specs that NVIDIA requires is deeply uncertain, but it's a risk that gets bigger every year. The third risk is concentration. SK Hynix's entire HBM business is effectively one customer, NVIDIA. 90% of their HBM goes to one company. If NVIDIA shifts roadmap, delays a platform, or diversifies suppliers aggressively, SK Hynix feels it immediately. These risks don't make the HBM story less compelling, but they're the reason you don't just buy memory stocks and forget about them. Here's the takeaway. The AI boom is real, and it has a physical constraint. Every AI chip on the planet needs high bandwidth memory. The companies that make that memory are overwhelmingly Korean. The cycle from 2022 to 2026 is one of the most dramatic in semiconductor history. From a 14.9 trillion won loss to a full-scale supercycle, driven not by the usual demand drivers, but by a structural shift in what computing needs from memory. The SK Hynix versus Samsung battle inside Korea is one of the most interesting competitive dynamics in tech right now. One company that bet, right, early, one that has the scale to come back, and underneath all of it, a Chinese challenger closing the gap, and a cyclical industry that has never, in its history, managed to stay at the top forever. This is the memory race that will define the next phase of AI infrastructure, and Korea is right in the middle of it. Next episode, we cover the other piece of the Korea story, how a defense industry no one was watching became one of the most important arms suppliers on the planet. Subscribe if you haven't already. I'll see you in the next one.